Um, this is kind of a different approach for me this year. What I've done in the past is just gotten right into y equals mx plus b. And having visited with a coworker across the way, and the more I think about it with my advanced classes, I think that what we're doing today, it's important that we do this first so that if you forget what y equals mx plus b or anything else is about as we go forward, you can always fall back on today's method. Today's method is definitely the most work of all the ways to graph lines, but it's the one that's going to carry you the furthest. If you're sitting taking a test, a standardized test like an ACT or a college test or something, and someone says, hey, make a graph of this function, or hey, graph this equation. If you forget all the little tricks about slope and y-intercept and where it crosses this and this, you can always fall back on what we're learning today. So what we're learning today, and I do have a paper assignment that goes with this, is how to just make a table of X, Y values and then play a game of connect the dots. And I wish that I had kind of seen the light, so to speak, earlier in my career, but I keep learning things as I go. Old dog learning new tricks here. So, anyways, what we're going to do today is we're going to graph these lines, but we're not going to take shortcuts. If you know any shortcuts, we're going to put them out of our mind. Today we're going old school, and we're going to make a table. So your tables, generally, most people make their tables vertically. If you're a horizontal table person, you do you. So the way we're going to make this is we're going to pick X's and then we're going to put them in and we're going to have the function or the equation spit us out the quote unquote answer. So with every X we put in, the equation is going to give us back a Y. And that'll be a point that we'll eventually graph on the line. And again, this is something we use this in my pre-calculus class every day. The ability just to put in an X and then get out a Y the importance of that cannot be overstated. And I will, over the coming weeks, I will show you much quicker and more efficient ways to graph lines. This is not our primary go-to. This is like our fallback method. But I figured I'd better give us this one first. So having said that, I could pick any number I want for X. Let me ask you a question. Don't write this down. Why would this be a bad choice? Bless you. Because the graph doesn't even go as far to the left as -8. And so if I'm thinking about trying to find a point that's on the graph, I want to be smart about working within the confines that I've kind of been placed with it, right? So -8, I could do the math, but I don't want to because then I'd have to try to graph it and it's not going to fit. So what would be a good X that we could pick?
-4.
I'll do -4 first, and then we'll talk about why it's also no good. Sometimes what happens is you don't realize you picked a bad one until you math it. And what I mean by math it is let's go up here to the equation. You see that little tiny red arrow up there. Change that X. You could do all this in your head. Like we're all big kids here. So if I put -4 in place of that X, what's -4 times -4? And what's 16 plus 4? 20. And we run into the same dilemma of I may have picked what I thought was a good X, but turns out it gives me a bad Y. So we kind of got to be smart about this on both ends of it, which is why 0 is a really good choice because if I put 0 in there, not only does 0 play well on this piece of graph paper, but what is -4 times 0? And 0 plus 4 is, I like that. So we finally have a point that we can fit on the graph. And so that's part of what your job is to be smart about choosing numbers that stay within the confines. I mean, if you want to go and get a really big piece of graph paper and graph the point 420, you can. It's just kind of a pain. So give me another good X. Anyone worked ahead and figured this out? One works really well. I agree. If I do one, then I just math. And I hope you all understand what I mean when I say to just math. This arrow up here is your buddy. We're going to keep changing that X into whatever we want. So in this case, what's -4 times 1? And what's -4 plus 4?
Yeah.
We got ourselves another point. And I do believe in this case that there's only one more that's going to, I mean, there's obviously infinitely many points we could pick, but to fit on the grid, provided there's only one more, and I believe it's 2. Because this is the last one where both the input and the output are going to stay on the grid. What's negative 4 times 2? And what's negative 8 plus 4?
Or negative 12.
Nice job. Negative 4. Negative 8 plus 4. You went the wrong way. Remember, plus 4, we go up closer to 0. And we now have the only 3 points. And I say, even if I went to 3, I'm off, right? I mean, there's no law that says I can't do it. It's just it won't fit on this particular grid. Because 3 would make negative 12 plus 4 is negative 8, and 3 negative 8 doesn't fit on the graph. So each problem is going to present to you different challenges as to which x's you should pick, based on do you like the x and also do you like the y that it gives you back. I didn't want to waste a bunch of class time with rulers, so we're going to get to that a little bit later. For now, what I want you to do is just help me plot these points on the graph. So I did put in my note card for today that we needed to talk about plotting points. Let's all make sure that we're good on our x, y. And never use the word over. You may use one of 4 words: up, down, left, or right. How do you graph the point 0, 4?
Right, and up for.
That's all you do. Because the 0 is in the x position, you do not move right or left. Remember, your first coordinate is your xy, or your x, excuse me. Your second coordinate is your vertical. So perfectly spoken, we're going to simply go up 4, all of us, and put a dot right there. How do I plot the point 1, 0? Perfect. Right 1. And because the y coordinate's a 0, we don't go up or down. And how do I graph the point 2, negative 4? Right 2, down 1, 2, 3, 4. And what's nice again about this is it's super powerful because, I mean, A, you don't need to know any tricks. You just need to know some basic math. And B, you can kind of grade it based on those 3 points are in a line. And I got to be honest, the probability of making 3 points in a line and having done every one incorrectly to make that happen, the chances are pretty small. So if you get 3 points that look like they're collinear, chances are you did some good work. So later on, when I'm done with this, we're all going to grab rulers and we will connect those and actually make lines. Get used to it. We're going to be graphing a lot of lines. So lines, I'll show you the way your lines will look going forward. Okay. Notice my line pierces out both ends of the grid. I'm sorry that it's a little bit off kilter there. And you have to put arrowheads on both ends of it like this. So when we get to graphing lines, no sticks, no line segments, right? Nice, bold, proud lines that go out one end, out the other end, arrows on both sides. Let's go to number 2.
You do realize that none of those. Uh-oh.
That my line is terrible. Yeah, I think I said that. I was aware of it. I just because I started with a phantom point, then the whole thing just went downhill after that. Yeah, Jojo.
Doesn't the line just go off into infinity?
It does. That's why
After-
that's why we had to put arrowheads on it. Yep. And without the arrows, you didn't draw a line. You drew what we call a segment. And you'll talk more about that next year in geometry. Lines go forever. Segments start and stop. We don't want start and stop. Okay, you should not have any Chromebooks out right now. So if you have one, please, for God's sake, shut it. Let's make another table for problem 2. Problem 2 is going to be way more forgiving than problem 1, meaning we're going to have a lot more flexibility, right? I think that we're a little more wide open. We're less constrained on what we could pick for x. What would be a good x to pick? 0 is always a great place to start. Why not? Put in 0. And again, I'll do a little red arrow for you. What's 0 minus 3?
Thank you.
So we have a point. Give me another one. Say it again.
1.
Fine. 1 minus 3. Good. Before anyone says 2, I want you to think about this. You do not want your points to be too close together. I kind of just wanted to get in the way before someone just logically said 2. What you want is to have your points spread out. It'll help to avoid making bad lines. And I'm not one to speak after that last dumpster fire of a graph, but we want to think kind of far away. Yeah, Jojo?
Be 0, or no, would 3 be a point? Is it we just let it?
It's fine. It's just I can go further away. What are you thinking? Yeah, 3's fine. I was really hoping someone was going to say 6. Thank you. I really want to go out far away because I don't want my points to be packed tight. Sometimes I just take what the problem gives me, but this one has said there's a lot. Choose wisely. If I put in 6, I've forced myself now all the way to the right. And then you always have to math. What's 6 minus 3? 3. So I now have another point. And I could even do another one. I could go as low as -3. I'm being aware as I go of where am I going to leave the grid. I don't want to leave the grid. But if you math, go up to where the red arrow is, what's -3 minus 3? And look at what we just did. We just made 4 beautiful points. And there were others we could have done, but I like how they're spread out. That's the goal. So help me plot some points. How do I get to the point 0, -3?
Yeah.
Down 3. Nice and clean. How do I get to the point 1, -2? Right 1, down 2. Remember, never ever say the word over unless you're saying a fraction. Like, what's the answer? 3/4. Like, the word over should never be used for giving someone directions. Okay. Up, down, right, left. How do I get to the point 6, 3?
Right, 6.
Right 6, up 3. And already this is looking good because those points look like they're collinear. So this fourth will be like our insurance policy. If he falls in line, chances are we're doing okay. How do I get to -3, -6? Left 3, down 6. And you don't have to say down negative. It's redundant. You could just say left, down. And I'll try to make a better line this time. No guarantees. That one is better. It's still not my finest piece of work, but it'll do. And again, notice I went out one end, out the other end, and without the arrowheads, it's garbage, but with the arrowheads, it is a finished product like this. Now, starting in question 3, I require that we have fraction knowledge. So this time we're going to be a little bit smarter, or we have to be a little bit smarter about what x's we choose. So same thing, we're going to make a table. Have I shown you guys the fish hook yet? Have we talked about the fish hook? Let me ask you a question. What's 3/2 times 8? Ready, go. It should take you under 1 second. You should already know the answer is 12. Let's try again. What is 3/2 times 10? Ready, go. Too slow. 15. Let's go again. What is 3/2 times 4? Too slow. 6. So the trick to this is whenever I'm choosing these numbers, I'm going to underline them in red. I'm choosing them because I want them to be divisible by 2. The trick to this is going to make you a way better mathematician, is to remember that when you want to multiply a fraction by a whole number, if the whole number can divide, you just make a little thing that looks like a fish hook like this. You go 4 divided by 2 times 3. You see how it looks like a little hook? That's how easy it is. So what's 8 divided by 2? 4 times 3, 12. What's 10 divided by 2? 5. 5 times 3, 15. This would not have gone so smoothly if I had asked you for 3/2 of 11. Why?
It's not.
Because 11, when it tries to fish hook divide by the 2, we hit a bump. We go, whoa, whoa, 11 can't divide by 2. The point I'm trying to make is that as we make our table on this problem, let's not be ding-dongs. We're in control. Let's pick x's that end well, that fish hook well. So
Try to.
let's try 2.
Wouldn't 0 work?
0 is always going to work. 0 is always going to be like your best friend when it comes to making tables. Yeah, so let's get that one next. If I pick 2, I like it, by the way, because it fish hooks nicely with the bottom of the fraction 2, right? So picture this being a 2 right here, and then fish hook it. What's 2 divided by 2? 1 times 3 is 3. And then you got to go that answer minus 2. 3 minus 2 is done. Grady asked, could we do 0? And the answer is wholeheartedly yes. Always grab 0. It's the most simple thing to do. What's anything times 0? 0. And what's 0 minus 2? -2. Would 6 be a good choice? Anything that's going to hook divide by 2 is a good choice, right? Fish hook that sucker down. What's 6 divided by 2? 3 times 3? 9 minus 2? So maybe it wasn't the best choice, right? Oh, I can't believe I just got a 6, 7. What are the odds? Unbelievable. I know. Or let's try 4. Yeah, we could try 4.
There's no 7 on the graph.
Right, and that's why I erased 6 and 7. Yep. Yep. And again, you saw me do it, I think, earlier. If you have one that's just barely off the grid, you can kind of guesstimate where that would have been. Like, could I go right 6 and up 7? Yeah, I would guess that 6, 7 would have been right here. You would agree. So if you wanted to leave it, it would be fine. You're not going to hurt anything. I wouldn't go too far off though. But what's 4? Fish hook it down. What's 4 divided by 2? 4 divided by 2 is 2. 2 times 3, 6 minus 2, 4. Could I do a negative? I could do like a -2, right? It doesn't, and people think like, oh, it's a negative. God dang, who cares? It's a positive times a negative. So just fish hook it like normal and just slap a negative on it when you're done. I'm not even going to say -2. What's 2 hooked down? 2 divided by 2. 1. 1 times 3, 3. So it's -3 minus 2, -5. When working with negatives, just take them out, do the problem, put them back in. Easy peasy. So let's plot these points and hope that they look like they make a line. How do I get to the point 2, 1? No.
Over two.
Right 2,
Right 2.
up 1. Good. How do I get to the point 0, -2? Just, yeah, you don't, again, have to say down and negative because it's redundant. Okay, the down covers the negative. And how do I get to the point 4, 4?
Right.
Correct. And these are looking great. Let's do this last one just for insurance purposes. How do I get to -2, -5?
2 down.
Perfect. And those could not be any more gloriously in line with each other. So again, in a little bit, when we're done, you'll grab rulers and you'll make some nice, beautiful lines through these points. Let's head to number 4. When we're making our table, what are we thinking about as we pick our x's? That is perfect. We want them to be divisible by 4. They don't have to be, but you're going to be in for a lot more gnarly, calculatory, kind of annoying stuff if you don't choose wisely. So choose smart x's. We can try 4. If you ask me, can we try? My answer is going to be yes. And we can try any number, right? Let's see what happens. Fish hook it. If you didn't learn the fish hook, then I'm sorry. I'm just going to do 1/4 times 4. And I left the negative out on purpose because I don't care. Fish hook it, right? What's 4 divided by 4? 1 times 1 is 1. So the answer to this one is -1 minus 4. Done. Right? So you do the fish hooky, the hard part, and then just add or subtract the number at the back. Easy peasy.
0.
0 is always going to be 1. If I ever see you make a table and don't use 0, I'm probably going to have a little word with you. Question your sanity. The good thing about 0 is that it takes this entire red box and just wipes it out. Just boom, gone. So what's the answer? Yeah, it means 0, but then you got to take away 4. So it's 0 minus 4 is -4.
8.
I like 8 a lot. All right. So again, off to the side, if I do 1/4 of 8, 1/4 times 8, fish hook it. What's 8 divided by 4? 2 times 1, except it's -2 minus 4 is -6. The only trouble with 8, 6 is that it's going to be off to the right. So while I said I loved it, I love it mathematically, but I don't love it graphically. How about we pick the only other number on the grid that's divisible by 4, like -4, right? Go for some symmetry here. And again, please, please, please just take the negatives out of your mind. You're all big kids and you know that the -1/4 times the -4 is going to be positive. So the heck with the negatives anyways. Fish hook it. What's 4 divided by 4? 1 times 1, +1 minus 4, -3. So this is where we cash it in and we graph the points and we hope, fingers crossed, that they look like they make a line. If they don't, then we have to go back and diagnose who's the oddball. And if you only have 3, it's sometimes hard to figure out who the oddball is because you could take any one of them out and the other 2 would make a line. So, but we're limited on this one. 3 is what the math gods gave us. So we're going to hope, fingers crossed, that this works. How do I get to the point 4, -5? Right 4, Down 5. I'm going to get you using these proper words confidently in the right order. How do I get to the point 0, -4? Down 4. Don't have to say down -4. How do you get to the point -4, -3? Left 4, down 3. Left 4, down 3. Remember, the first number is your sideways number. The second number is your up and down, which I understand is a backwards of how we teach you slope. With slope, you've got to do your y's first and your x's second, right? Good. So those look pretty dang good. Let's head to number 5. You can connect those dots later. What are we thinking this time as we pick our x values? Let's pick numbers that are divisible by 3.
3.
I'm down. Let's pick 3. And again, I do not want us having a lot of conversations about negatives, okay? I've said it again and again and again and again. The fact that there's a negative right here doesn't change how successful I should be. I'm going to do my math like I always do. I'm just going to be cognizant of the fact that a negative times a whatever is a whatever, right? So fish hook it. What's 3 divided by 3? 1 times 7. So this is -7 -2, -9. I don't much care for that one. So let's maybe go somewhere else. Like, how about 0? And again, 0 wipes out that entire red box. Gone. What's 0 -2? I like that one. I think we should think about heading in the other direction. Like, why don't we try a -3? Because what's happening here is if I do a negative where that arrow is pointing, then I'm smart, you're smart. We know that a negative times a negative will go positive, and then I can take away 2 and hopefully not go down too low, right? So fish hook it. What's 3 divided by 3? 1 times 7. And it is a +7, and 7 minus 2 is 5. Right? We can try 6. I do think it's going to go way off the grid for the record, right? 6 is fine itself, but watch what happens. You get, okay, so you're off the 6. Okay, so -6, let's try. If you put in -6, you get 6 divided by 3 is 2. 2 times 7 is 14. It is +14 minus 2 is 12.
Okay.
Yeah, I mean, I don't know what we're missing here. Listen, I wouldn't go down any road where your x value is not divisible by 3. I would stay with 0, 3, 6, 9, -3, -6, -9. I think we might have milked this dry. Let's try these points and see what we're up against here. I'm going to fix that. Okay, so 0, -2 is right here. -3, 5 is right here. Do you see how far apart those points are? That's why we can't find any more good ones, because the next good one is either going to be up here where this green dot is, and we can't find that, or down here where this purple dot is. And we don't have access to those. I mean, we do, but they're off the grid. So we're going to take the 2. Generally, only doing 2 is a pretty bad practice, but we'll take what we get here.
Why do you have to have like a designated like problem to do? Can't we just start up with not swimming the line and the problem?
You mean, why do we have to have this?
Yeah.
Because what we're learning right now, the standard that we're trying to learn is, can students graph an equation when given an equation? Right? We're not just, this isn't like art class. We don't get to just put dots and make a pretty picture, although that would be fun.
I do. Yeah.
Oh, okay. So having said that, let's head over to number 6. So again, I've given you an equation, y equals 1/2 of x, and we're going to try to represent that relationship in the form of a graph. So I'm going to use this weird line that's already on my board here. And here we go. What are we thinking about? What are good x's? 0 is always good, but generally speaking, what are good x's? Generally speaking, what are good x's? Thank you. Numbers that can divide by 2. That's a generalization. You are giving me specifics. Generally speaking, I want numbers that are even. How about -6? Does that work? How about 6? Does that work? Let's take those 3. Let's go. Quick, quick, quick. What's 1/2 times 0? 0. Next one, fish hook it.
3.
It's not 3.
3.
It's -3. Last one, +6 is +3. And there are some more that we could do. We could do 2, 4, -2, -4. But man, if you give me 3 points that are this far spread out, I don't need anything else. So let's see how they look. Let's put 0, 0. That means I don't have to go anywhere. Do you guys remember what that point's called in the middle? The origin. Very good. And then let's graph -6, -3. Walk me through it. How do you get there?
Left. Um,
Thank you. That was well spoken that time. Good job. And how do we get to the point 6, 3? And those look pretty darn good, right? So that is what we're doing. I think I only put 6 on there for you. I didn't figure we needed any more than that. For this assignment, there are 2 sides. On side 1, you're going to fill in the tables. The tables, everything's chosen for you. You don't get freedom of choice on this worksheet. We're just practicing. So on the worksheet, the X's are already picked. You put them in, find the Y's. Have you guys ever done these worksheets with the decoders on them? You'll be seeing more of them coming up because this workbook that I use does a really good job with the graphing unit. Um, uh, I'll coach you through it. Let me hand this out first, and then I'll coach you through a couple of problems. Sound good? Okay. Then you know that they spell out dad jokes. And as with any homework assignment, like there's nothing stopping you from doing something dishonest. And by that, I mean, like you could just, your friend could tell you what the joke says and like I don't know why you would, but you could just write it in. Like, yeah, it just doesn't make any sense, right? So the way these happen is you do them one problem at a time. And every time you do a problem, you crack part of the code. And then when you're done, it should spell a joke. And I would just ask of you respectfully that you not say the jokes out loud, just because it sways people and it causes them to not let the math just take care of itself. So the idea here is that we want to do one little bit at a time. So our first table is number 1, and the table says -2x. Notice again that we're not in charge of the x's. They were chosen for us. So for the first x, it's 1, right? What's -2 times 1? -2. So notice, like I could stop right now and go crack part of the code. You see the number 1 next to it, right? So that means down here in box number 1, where I just drew that arrow, we need to put a letter. And the way we're going to figure out the letters, we're going to go to the key. So I need to go find my answer, -2, and you see that it's right there. So we're going to go to box number 1, and we're going to put an H. All right. In the next one, they asked us to put in a 4. And so what is -2 times 4? -8 is perfect. And then I'm going to go find that answer. So I'm on box number 2 now. That's why the 2 is circled next to the problem, right? That tells me what part of the code to do. And so I go find -8 in the answer key, the code key over here, and it's got a letter with it, E. So in box number 2, I'm going to put an E. And we're going to do 2 more, and then we'll go to the other page, because after we do this, we then have to go and make a line. All right. So what is -5? What's -2 times -5? +10. And that wouldn't have worked for us, but on this worksheet, these grids, when you turn your paper over and look, you can see these grids are a little bit taller than ours, the last ones. So we have a little bit more room to work with here, right? So I'm going to go to box number 3. And what letter am I going to put in there?
R.
R, because it's up there where the code key is, right? The answer is 10, and that goes with the letter R. So in box 3, we put an R. And then we're going to do one more, and then we'll go make a line. So if I put in 3, what's -2 times 3?
6.
Nice. Okay, so this is going to be box 4. What letter are we going to put in?
B.
B. Good. So this is a good time to stop. And we're going to go to the other page. I didn't mean like stop for good. I just meant like temporarily stop. So we're going to go to the other page, and we're going to go graph those points. I just need to figure out which page I was on. That is 140. There it is right there. All right, so obviously we're going to use the graph next to 1 since we just completed problem 1. So could you guys read the points off to me that we have from our table? Okay, let me see if I can zoom in a little bit here. So we have 1, -2, which is right 1, down 2. What was another point that we had? Or say it again. 4, 1, 2, 3, 4 to the right, and then 8 down. 1, 2, 3, 4, 5, 6, 7, 8, like this. What's another one? -5, 1, 2, 3, 4, 5. Up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These are looking pretty good so far. I believe we have one more. What was it? Say again. Right 3, down 1, 2, 3, 4, 5, 6. Good. And now with your ruler, you'll make a line that goes right through all 4 of those points. Remember that your line needs to go out. It needs to pierce out of the graph on both sides, and it needs to have arrowheads on it. And that's it for the first one. 1 down, 7 to go. Guys got it? I can't make a line with what the way I've got this set up right now, so I'm not going to try. It'll look really bad, but you guys have rulers. Do you have any questions? Okay.